All right, guys, are there any questions from yesterday's assignment? What we're talking about today, well, let me make this statement. So the video that I posted for yesterday wasn't the video that we had in here. For some reason, when it was finishing processing, where you guys, after I save it and name it, it quit early, and when I looked at it, the last 15 minutes of the video were gone. So I uploaded 8 hours video for that, in place of it. It might be a little bit different, because they're different dynamic. I'll leave it at that. So that video is up there, but it's going to seem a little different than what we covered in class, if that makes sense. Okay. Now what we're looking at today is parallelograms. Yes, it is. Thankfully. I've done that before, made it all the way to the end of class and realized it hadn't even started. Or that I didn't turn the microphone on, so it does. Now, a parallelogram, because y'all know the definition because y'all looked it up the other day, is a four-sided figure with two sets of parallel lines. It's a quadrilateral with two sets of parallel lines. Defines our parallelogram. So any quadrilateral with two sets of parallel lines will be called a parallelogram. And whenever we're naming figures, we're always going to want to use the most specific name that we possibly can. And if we don't have any properties or any way to name it, we will always default back to quadrilateral. Because a quadrilateral is just going to define any four-sided figure. If it has four sides, we're going to call it a quadrilateral. Now, if we know that it has four sides and two sets of parallel lines, we're not going to call it a quadrilateral anymore. We're going to call it a parallelogram because we have a more specific way to name it. Now, parallelogram opposite side theorem. If a quadrilateral is a parallelogram, then its opposite sides are congruent. If it's a parallelogram, then its opposite sides are congruent. So for us here, PQ and RS are going to be congruent. We also have that QR and PS are congruent. The opposite sides are going to be congruent. It actually also works out that the opposite angles are congruent. So the second part of that, if it's a quadrilateral, then the opposite angles are congruent to each other. So we can say that angle Q and angle S are congruent, as well as P and R. So if it is a parallelogram, the opposite sides are congruent to each other and the opposite angles are congruent to each other. Okay. So let's look at the first example. So when we look at this problem here, we want to find the values of x and y. Well, this is a parallelogram because we do have four-sided figure and the opposite sides are parallel. We have two sets of parallel lines. So that means that the opposite sides are going to be congruent. So these two sides are congruent and these two are congruent. So we can say that x plus 4 is equal to what? 12. Because those two sides are going to have the same length. What can we say about the angles? $65 and y are going to be congruent. So y is equal to 65. And we would also have that the other two angles are congruent to each other, but We don't want to know anything about those. So we found the measure of angle y. We just need to find the measure of angle. So what can we do? Subtract 4 from both sides, which tells us x is equal to, bless you. And that's it. Let's look at the next one, because that's all there was to that problem. So if we look at this here, well, we know that this is a parallelogram. We have two sets of parallel lines, and it has 4 sides. So I can say there. We also know that the opposite sides are going to be congruent, and the opposite angles are congruent to each other. So what can we set equal to each other to find x and y? 2x is equal to 54. What else do we know? 3y minus 1 is equal to 20. Which one do we want to solve for first, x or y? X. So what do I need to do first to solve for the value of x? Divide both sides by 2, telling us x is equal to 27. And that's it. We found the value of x. Let's find the value of y now. So what can we do first? Add 1 to both sides. And that will tell us that 3y is equal to 21. And then we would divide both sides by 3, telling us y is equal to 7. And that's it. That's all we have to do for this here. Any questions on this here? FG would be 8. Because the opposite sides are congruent, and our opposite angles are congruent as well. And that's it. That's even easier than the first two. Do we feel comfortable with this here? Okay. If we feel comfortable with this here, we can go on and move on to the next part. Now the next part here, the consecutive interior angles theorem, states that if two parallel lines are cut by a transversal, then the pair of consecutive interior angles formed are supplementary. Well, we went over this last year when we talked about alternate interior, alternate exterior, consecutive interior angles. We talked about this at the same time. Now the reason that they bring this up is because a pair of consecutive interior angles in a parallelogram is like this here. So the two angles that are next to each other inside a parallelogram are going to be supplementary. They're going to add together to be 180. If a quadrilateral is a parallelogram, then its consecutive interior angles are supplementary. They add together to be 180. And coincidentally enough, the parallelogram diagonals theorem, if a quadrilateral is a parallelogram, then its diagonals actually bisect each other. They cut each other in half. They don't do anything to the angles. They don't bisect the angles or cut the angles in any particular way. They just bisect each other. They cut each other in half. And this will work every single time. Questions on this here? Okay, find the missing angle. What do we know about these two angles here? They're not going to be congruent. Because if a quadrilateral is parallelogram, then consecutive angles are supplementary. So these two here are going to add together to be 180. So we can call this x. So we can say that x plus 80 is equal to 180. Really, what are we going to do? We're going to subtract 80 from 180. So this here would be 100. Now, I didn't ask for this, but what would be the measures of angle W and X? So X would be 100 and W would be 80, because again, opposite angles in a parallelogram are congruent. And all of these here, even though we don't have the two parallel lines drawn in, they are going to be quadrilateral or parallelograms. Let's look at this one here. What is the measure of angle L? 98. Because the opposite angles are congruent. Now let's go on and find the others. How can I find the measure of M or K? Because they add together to be 180, and then we would subtract 98 from both sides. Or really, we could have just subtracted 98 from 180, and this here would be 82. Because we could have also just added up from 98 to 180, because 2 added to 98 would give us 100, and then we would need 80. So the other two angles are 82 and 82. Question. What would I get if I added these four angles together? 360, because any four-sided figure, the sum of its interior angles is going to be 360 degrees. Let's look at this one here. This one here will be the last one we do of this type, and then we'll move on to something that looks a little different. Can you give me one of the angles here? It would be 70. How can we find one of the other ones? 70 plus x equals 180, and we would subtract 70 from 180, yes? Which would give us 110 degrees. So the other two angles are 110. Any other questions on this here? Let's look at the next one. This one here is a little bit different. Which angle do we know for sure? We know W is 60, so which other one would be? Y would be 60. Because the opposite angles would be congruent. Which part? XVW, yes. It would exactly be 52 degrees. Now the reason that this does work is going off the fact that these two lines here are parallel. So 52, the two 52s are alternate interior angles. So they would be the exact same. Now it's very almost intriguing, not intriguing, tempting to say that this missing angle here is 52 degrees, but it's not. Because this diagonal does not bisect the angle. But what we do know for sure is that 52, and we'll call this, well, they took x and y as variables. So I can just call it A, I'm just picking a variable, that 52 angle measure A in 60 degrees, those three will add together to be what? 180. So we can say A plus 52 plus 60 is equal to 180. Because no matter if they're cut in half or cut bisected, not bisected, or had something cutting them or splitting the angle apart, or both of them, we have the two diagonals written in, those angles as a whole will still add together to be 180. Now we can do 52 plus 60, which would be 112 is equal to 180. Then we would subtract 112 from both sides, telling us A is 68. Yeah, that would make a little bit of a difference. A lot of the numbers like 180 to work out for most of them, because 180 is a straight line. Any questions on this here? Questions on this one? Because this isn't really changing anything, it's the exact same thing, just different numbers. Okay. What would we do for this one here? Yes. Is equal to 180. So this one here is going to be one of the few where we can't just subtract the number from 180 because the variable isn't just x or a variable by itself like we've had on the last few. Now we can combine like terms. 9x plus 6x is 15x plus is our 15 and 15 would give us 30. Then what would we do next? We would subtract 30 from both sides, which will tell us that 15x is equal to 150. And then we would divide both sides by 15, telling us x is equal to exactly, it would be 10. And they wanted us to find what? Missing angles. So it didn't ask, we needed to find the value of x to be able to find the angles. Now one of them is 9 times x plus 15. Well, it would be 9 times 10 plus 15. 9 times 10 is 90 plus 15 is 105. So this angle right here would be 105. What do we think the other angle is going to be? Because we know that these two angles have to add together to be 180. And we can check it to make sure. 6 times 10 plus 15. Well, 6 times 10 is 60, and 60 plus 15 is 75. And it does work out that W is 105 and X is 75. And that is it. Questions on this here? Okay, now we're going to look at the second half about the diagonals being bisected. This here is telling us that Km, the whole distance is 23.4 units. doesn't give us a measurement, so we can just say units. And it wants us to find the distance from y to m. Well, if we know the diagonals of a parallelogram bisect each other, cuts it in half, so these two are going to be equal. So what can we do with 23.4? Divide by 2, because it's cutting it in half. So we can take 23.4 and divide it by 2, which would be 11.7. So ym is 11.7. And the reason we don't put a line segment over ym is because we're talking about its measure, not the line itself. Questions on this here? Let's look at the next one. Well, they tell us RT is 19.8. They want us to find the distance of PR. Well, what's TP? 19.8. Well, if we want the whole thing, we can just add it together or multiply it by 2. 6. Carry the 1. Well, 9 and 1 gives us 10. Leaves us with just 9, and we have 39.8. So RP is 39.6. No idea why I said 39.8. 39.6. Questions on this here? Oh, let's look at this one. It tells us that UH is 19, and it tells us that FH, the whole thing is 5x minus 7. It wants us to find the value of x. Now, that kind of makes sense because just telling us to find the value of FH wouldn't mean a whole lot. Because what is the value of FH? Well, HU is 19, yes? UF would be 19. So if I wanted to add these two together, 19 and 19 would be almost 38. Because we could use, technically we could use kind of an addition of approximations, because 19 is close to what whole number? 20, yes? It's off by 1. Well, they're both close to 20, so 20 plus 20 is, but each one was off by how much? Minus 2 would give us 38. We can use approximation numbers. So 38. So we know that the whole length is 38. Well, what did they tell us? It is also, so 5x minus 7 is equal to 38. First thing we can do is add 7 to both sides, which tells us that 5x is equal to 5. Then we would divide by 5, which tells us x is equal to 9. That's it. Any questions on this here? Are you ready for the next one? And this is the last one, yes? Okay, so let's see this here. KU is 3x plus 3. is 4x minus 4. Find the value of x. Well, what do we know about these two segments? They are equal to each other. So I can say 3x plus 3 is equal to 4x minus 4. Realistically, if we were doing this mathematically rigorous, we would actually just say that Ku is equal to by definition. Ku is 3x plus 3, is 4x minus 4 by the definition of, or property of substitution. Then we can actually solve, but doesn't really change much. What can we do first? Unfortunately, we can't because they're on opposite sides of the equal sign. We can add 4 to both sides, yes. And part of the reason we add 4 to both sides is, well, over here we would have 3x plus 7 is equal to, well, 4x doesn't change, but negative 4 plus 4 is 0. So it removes it from one side, but keeping the equation balanced. Then what can we do? And that tells us that x is equal to 7. And that's it. Any questions on any of this here? We good with this here? And that's it. That's all we're doing for today.